This is lesson 4.5, Proving Triangles Congruent by ASA and AAS, starting on page 278. Number 1, we want a two-column proof. Given that CB bisects angle ABD and angle ACD, we want to prove that triangle ABC is congruent to triangle DBC. Okay, so we know that CB bisects angle ABD and angle ACD, because that is given. So if CB bisects angle ABD, it splits angle ABD into two congruent angles. So angle ABC will be congruent to angle DBC. Also, it bisects angle ACD, so it splits ACD into two congruent angles. So angle ACB is congruent to angle DCB. And that's by definition of angle bisector. We also know that BC is congruent to itself, and that is by the reflexive property. So we can say that the two triangles are congruent. By angle, side, angle. Notice in triangle ABC, we have these two angles marked, and we have the side marked in between those two angles. Likewise, in this triangle, we have these two angles marked and the side marked in between those two angles. So that would be angle, side, angle. For number 3, we want a paragraph proof. So we are given So we make sure that that information is marked in our diagram, which it is. Angle K is congruent to angle M, and JK is congruent to JM. Okay, so We know that these two angles will be congruent, so KLJ and MLJ are congruent because it's given that JL bisects angle KLM, so it will split KLM into two congruent angles. Okay, therefore, our two triangles are congruent by the angle-angle side theorem. So, in triangle JKL, we have two angles and the non-included side, and in triangle JML, we have two angles and the non-included side marked. So that's angle, angle, side is congruent to angle, angle, side. For number 7, we want a paragraph proof. Given that angles W and Y are congruent and sides WZ and YZ are congruent and XZ bisects angle WZY, that triangle XWZ is congruent to triangle XYZ. So we are given that angle W is congruent to angle Y and WZ is congruent to YZ. Okay, so we know that angle XZW is congruent to angle XZY because XZ bisects angle WZY. So it splits it into two congruent angles. So triangle XWZ will be congruent to triangle XYZ by angle side angle because we have two angles and the included side of one triangle congruent to two angles and the included side of the other triangle. So notice where the side is at, it's in between these two angles, and this side is in between these two angles. So that's angle side angle congruent to angle side angle. For number 9, we want a two-column proof given that V is the midpoint of YW and UY is parallel to XW. We want to prove that triangle UVY is congruent to triangle XVW. So let's state our given information. Okay, so first of all, based off the fact that V is the midpoint of YW, then that makes YV congruent to WV by definition of midpoint or midpoint theorem. Also, since it's given that UY and XW are parallel, then my alternate interior angles here will be congruent and my alternate interior angles here will be congruent. So angle U is congruent to angle X, and angle Y is congruent to angle W. That's by the alternate interior angles theorem. So that gives us enough information to say that triangle UVY is congruent to triangle XVW by angle, angle, side, since this side is not in between these two angles. So that's angle, angle, side. Likewise here, angle, angle, non-included side. For number 11, we want to write a flow proof. We're given that angles A and C are right angles, and angles ABE and CBD are congruent, and sides AE and CD are congruent, and we want to prove that sides BE and BD are congruent. So we can state some of our given information. So angles A and C are right angles, and that's given. Based off of this fact, we can say that A and C are congruent because all right angles are congruent. Then we can state some more given information. And we'll mark this given information in our diagram. AE is congruent to CD. So if we put these three things together, we have a pair of angles here, a pair of angles here, and a pair of sides there. So if we look in our diagram, the side is the non-included side. It's not in between the two angles, so that will be angle, angle, side is congruent to angle, angle, side. And based off the fact that the triangles are congruent, then their corresponding parts will be congruent. So BE and BD are in corresponding locations on these two triangles. So corresponding parts of congruent triangles have to be congruent. Therefore, BE is congruent to BD by CPCTC. Number 15, find the value of the variable that yields congruent triangles. So for triangle MHJ to be congruent to triangle PQJ, then I have an expression here for JQ or QJ. QJ is the second and the third letter, which corresponds to the second and the third letter here, HJ. So if I look at HJ in the other triangle, it says that that length is 9. So I need to set 2y minus 1 equal to 9 and solve for y. Add 1 to both sides and divide both sides by 2, and y is equal to 5. So if y is equal to 5, then these two triangles will be congruent. For number 17, we want to write a paragraph proof given that AE is perpendicular to DE and EA is perpendicular to AB, and C is the midpoint of AE, that CD will be congruent to CB. So we'll first start with this idea that these lines are perpendicular. So since AE and DE are perpendicular and EA and AB are perpendicular, then that makes angles A and E right angles by the definition of perpendicular lines. And since they are both right angles, they'll be congruent because all right angles are congruent. Okay, we also know that C is the midpoint of AE, so that will make AC congruent to EC by definition of midpoint, or by the midpoint theorem. Okay, so by the midpoint theorem, AC is congruent to EC, since C is the midpoint of AE. And angle BCA and DCE are congruent because they are vertical angles. So that means that triangle ABC and DEC are congruent by angle, side, angle. We have two angles and the included side congruent to two angles and the included side. And that forces CD to be congruent to CB because they are corresponding parts of congruent triangles. For number 19, we want to write a two-column proof given that angles K and M are congruent and KP is perpendicular to PR and MR is perpendicular to PR. We want to prove that angles KPL and MRL are congruent. So we'll start by stating our given information. So, since we know that KP and MR are both perpendicular to PR, then they will form right angles at their intersection. So angles KPR and MRP are right angles. And that's just by the definition of perpendicular lines. Perpendicular lines form right angles. Okay, so if they are right angles, then we can say that KPR and MRP are congruent because all right angles are congruent. We can also say that PR is congruent to PR by the reflexive property. And therefore we can say that triangles KPR and MRP are congruent because we have an angle, and a non-included side congruent to an angle, and a non-included side. So angle, angle, side. And since those two triangles are congruent, then we can say that KP is congruent to MR because they are corresponding parts of congruent triangles. So by CPCTC. Next, we can say that angles KLP and MLR are congruent because they are vertical angles. And now we can say that triangles KLP, so this triangle is congruent to MLR, this triangle right here, because we have an angle, and a non-included side, congruent to an angle, and a non-included side. So they are congruent by AAS. And finally, if those two triangles are congruent, then their corresponding parts will be congruent. So we can say that KPL, this angle right in here, has to be congruent to MRL, this angle right in here, because they're corresponding parts of congruent triangles.